We ourselves are working mostly on bone marrow cells rather than umbilical cord cells, but there are very similar principles that apply to umbilical cord cells, and these are cells as well that I think have very great potential for different types of disease. I think what we will find over the coming years is that different types of adult stem cell, maybe from umbilical cord, maybe from bone marrow, we can also get them from adipose tissue, from fat under the skin. And I think we will find that different types of these cells will be useful for different types of disease. So I think it's extremely important that we carry on with research into all of these different types of non-embryonic stem cell.
Well, regenerative medicine using adult stem cells has many applications. We've already seen many applications through the use of bone marrow and cord blood to cure practically 100,000 people by now from a variety of cancers and blood diseases. But now the area is moving into new cell types, such as those from fat or adipose tissue, as well as new diseases. We're looking at very substantial improvements in the outcomes of heart attack, stroke, diabetes, even lung disease like emphysema. These are some of the areas. Furthermore, we see the opportunity for reconstruction in the case of, say, post-operative difficulty after a cancer. It may be possible to reconstruct or help build the body back again using, in particular, the fat-derived stem cells. And these often work together with the cord and bone marrow. So we look at the opportunity with more than one cell type to treat multiple diseases in the body. Yeah, cord blood has been very effective over the last 2 or 3 decades now to save lives with a multitude of cancers and blood diseases. In many instances, the cord blood can be preferable to adult bone marrow, in fact, in the fact that it can repopulate the blood tissue of people who've had enormous amounts of chemotherapy sufficient to combat their cancer. And you have to have a rescue for that. The rescue is found in cord blood. Now, many people are also looking into the cord tissue, and it turns out that the cord tissue is rich with mesenchymal stem cells, other kinds of stem cells that can be used in a variety of regenerative medicine applications, both for tissue healing and rescue, such as from heart attacks and strokes, but also for construction of bone, cartilage, or reconstructive surgery. So the cord tissue and the cord blood has many applications, and in fact has saved many decades of thousands of human lives so far.
Well, umbilical cord blood was first discovered to have stem cell potential in the early 1900s, and people thought that it might be useful in some way, but there was a great confusion. It took nearly 50 years for people to understand what a fantastic opportunity umbilical cord blood is. In my belief, umbilical cord blood has a role not just for transplantation in regenerative medicine, it is also going to be extremely important to help develop new drugs for the future. My research team have been working on the umbilical cord tissue for many years because we believe that it is probably the richest source of untouched mesenchymal stem cells, which have the potential to form bone tissue, cartilage tissue, and even in our laboratory we have turned mesenchymal stem cells into hepatic liver tissue, nerve cells, and many other tissues. And we believe that if you're able to keep this tissue, you may be able to use it for many years for that child or for another child in the family. I believe that there are 3 pillars of healthcare for the future: new drugs, new surgery, and stem cell therapies, sometimes used alone and sometimes used in combination as something that we call regenerative medicine. I believe that regenerative medicine is going to become a standard, important therapy for the future. In fact, umbilical cord and cord blood are the most easily accessible tissues in the world, with 130 million children born every year, according to the World Health Organization. This is certainly a tissue that we must consider. I believe that we have to have a debate about different types of stem cell banking in general, and that we must have the idea that we should consider to keep stem cells not just for the people who donate them, but also for the public. We have to think to the future to have new types of cord blood banks that will be able to help both the public system and the families who are kind enough to donate them.
V každom prípade regeneračná medicína sa začala dávno pred súčasným chápaním regeneračnej medicíny. Začala s centrami popálenín a s aplikáciou keratinocitov, respektíve fibroblastov do popáleninovej liečebnej praxe a následne do rekonštrukčnej chirurgie. Následovala aplikácia kmeňových krvotvorných buniek, ktoré same v sebe obsahovali, ak pochádzali z kostnej drene, aj adultné kmeňové bunky nehematopoetickej rady. V súčasnosti sa regeneračná medicína chápe ako aplikácia adultnej z pacienta alebo z iného darcu odvodenej kmeňovej, tzv. Kmeňovej bunky. Väčšinou sú to bunky z kostnej drene, respektíve bunky z tuku alebo z iného tkaniva, ktoré sú eticky nezávadné. Nehrozí tam žiadny transfer cudzích ochorení a pri rešpektovaní všetkých bezpečnostných zásad sme schopní vyprodukovať transplantát buniek, ktoré indukujú reparačné alebo regeneračné procesy v danom tkanive. Pupočník na základe aj našich experimentov obsahuje tak vo svojej, respektíve placenta sama so všetkými svojimi tkanivami, obsahuje extrémne veľké množstvo kmeňových buniek aj mezenchymálnej rady. My sme sa vo svojich experimentoch zamerali hlavne na plodové obaly, amnion a chorion, kde sme dokázali, že existujú bunky, ktoré nesú aj znaky embryonálnych kmeňových buniek, ale zároveň nesú už aj znaky adultných kmeňových buniek. Postupnou kultiváciou sa tieto znaky vytrácajú, znaky embryonálne vytrácajú, čím dostávame veľmi validný zdroj mezenchymových kmeňových buniek, využiteľných pre terapiu. Dnes existuje niekoľko klinických štúdií vo svete, v západnom svete, ktoré sú používané hlavne pri autoimunitných a neurodegeneračných ochoreniach.